The night sky was never still. We were just too slow to notice. For most of human history, the stars looked fixed, calm, silent, almost eternal. You could walk outside, look up, and feel like the universe was a painting, a black canvas, a few thousand points of light, a peaceful ceiling above a noisy world. But that was an illusion. The sky is moving, exploding, flickering, spinning, breaking apart, sending warnings. We simply did not have the eyes to catch it happening in real time. Now we do. And that changes everything. When I was a kid, I used to think astronomy meant patience. You pointed a telescope at the moon, or Jupiter, or Saturn, and you waited. Sometimes the clouds ruined the night. Sometimes the image shook in the eyepiece. Sometimes all you saw was a blurry white dot that was supposed to be a planet. But even then, there was something beautiful about it. The sky felt slow enough for a human being to follow. Tonight, that version of the sky is ending. A new observatory in Chile is beginning to turn the night into something else. Not a painting, not a postcard, a live feed, a warning system, a machine that notices when the universe changes. It is called the Vera C Rubin Observatory. And its job is not simply to look at the sky. Its job is to watch the sky move. That sounds like a small difference. It is not. Rubin carries the largest digital camera ever built for astronomy, a 3,200 megapixel eye. Each image covers a huge patch of sky. Not one star, not one galaxy, a whole region of the universe at once, over and over again, night after night, for 10 years. The goal is called the Legacy Survey of Space and Time. That name sounds calm, almost academic. But what it really means is this. For the first time, humanity is going to build a time-lapse movie of the universe. Not an artist's animation, not a simulation, a real one. The same sky, photographed again and again, until the quiet parts are separated from the moving parts. And when you do that, the universe stops looking frozen. It starts looking alive. Or at least, restless. In its early imagery, Rubin captured millions of galaxies and stars, along with thousands of asteroids, in just a little over 10 hours of test observations. That should make us excited. It should also make us uncomfortable. Because those objects were not created by Rubin. They were already there. Rubin simply saw them. And that is the first strange lesson of this new era. Discovery is not always about the universe changing. Sometimes it is about our ignorance shrinking. The sky is not suddenly more crowded. We are finally seeing the crowd. Before Rubin, astronomy often worked like a series of portraits. A telescope looked deeply at one region, then another telescope looked somewhere else. Some surveys watched the sky repeatedly, but never with this much reach, speed, and detail at once. Rubin changes that balance. It is wide, it is deep, it is fast. That combination is rare. A telescope can usually do one or two of those things well. Rubin is trying to do all three, and that is why it matters. Because the universe is full of things that do not wait for us. Asteroids cross the frame, stars flare, supernovae explode, black holes feed, distant galaxies brighten and fade. Objects from the outer solar system creep through the darkness. Some events last years, some last days, some may last only hours. If your telescope is looking somewhere else, you miss them. Rubin is designed to miss less, and that sounds comforting. Until you realize what comes next. Alerts. Not a few. Not a few hundred. Millions. In February 2026, Rubin issued its first scientific alerts. On one night, it sent around 800,000 notifications about changes in the sky. Eventually, that number is expected to rise to millions every night. Think about what that means. A normal person gets stressed by too many emails. Astronomy is about to get millions of messages from the universe every night. Most of them will not be dangerous. Most will not be world-changing. Some will be known asteroids. Some will be variable stars. Some will be distant explosions. Some will be noise. Some will be mistakes. But hidden inside that flood may be the things we most need to catch early. A near-Earth asteroid, a rare supernova, an interstellar visitor, a black hole suddenly waking up, a cosmic event that lasts just long enough to be noticed if the right machine is paying attention. This is where the story becomes bigger than one telescope. Rubin is not just giving us better images, it is changing the rhythm of astronomy. Old astronomy often asked, "What is out there?" New astronomy asks, "What changed since last night?" That is a very different question, because change is information. If a point of light moves, it may be an asteroid. If it brightens, it may be a supernova. If it flickers strangely, it may be a variable star, an active galaxy, or something we do not understand yet. If it appears once and never returns, it may become a mystery. The universe is no longer just a place. It is a sequence of events, and Rubin is trying to catch the sequence before it disappears. The method sounds almost simple. Take an image of the sky, compare it to an older image of the same region, subtract what stayed the same, study what remains. The leftovers are the interesting part. The changed pixels, the moving dots, the sudden flares, the things that were not there before. But simple ideas can become overwhelming at cosmic scale because the sky is not clean. The atmosphere distorts light. Satellites streak through images, cosmic rays hit detectors, bright stars create artifacts, weather changes, instruments behave imperfectly, and behind every real discovery is a pile of things that only look like discoveries. This is the second lesson. Seeing more does not automatically mean understanding more. It means sorting more. The problem is no longer only blindness, it is overload. Rubin will create so many alerts that no human being can inspect them one by one. Astronomers will need algorithms, brokers, filters, networks, other telescopes ready to follow up. The machine will notice, other machines will classify, humans will decide what deserves attention. In a strange way, the universe is forcing astronomy to become more like air traffic control, not because stars are airplanes, but because the sky is becoming too active to watch casually. You need systems, priorities, escalation, a way to know which blinking light matters. This is where I think the story becomes strangely human, because the more we can see, the more responsibility we inherit. A hidden asteroid is just a rock. A detected asteroid becomes a decision. Do we track it? Do we announce it? Do we calculate risk? Do we spend telescope time on it? Do we worry the public? Do we wait? The sky was always full of motion. But once we can measure that motion, it becomes ours to interpret. That is not always comfortable. For most of history, ignorance protected us emotionally. If an asteroid passed nearby and nobody saw it, nobody was afraid. If a star exploded in a distant galaxy and no telescope caught the first light, nobody felt like they had missed anything. But now, every night, machines will tell us what changed. And some of those changes will be beautiful. Some will be useful, some will be terrifying. The universe will become less silent, but also harder to ignore. There is another side to this. Rubin may help us find things we did not even know we were missing. New classes of explosions, strange variable stars, small bodies in the outer solar system, maybe even clues about the unseen structure of the universe. Because when you watch enough sky for enough time, patterns begin to appear. And sometimes the pattern is the discovery. This is what makes Rubin different from a normal telescope image. A single image can be beautiful. A decade of images can become a memory. Not human memory, cosmic memory. A record of what moved, what died, what brightened, what vanished, what returned. The sky will have a history written in data. And future astronomers may look back through that history the way archaeologists look through layers of a buried city. One night may seem ordinary. 10 years may reveal a universe we were never patient enough to see. That should make us hopeful, but I keep coming back to the same thought. The night sky may begin to feel less peaceful, not because it changed, because we did. We are building instruments that remove the comfort of stillness. We used to look up and see eternity. Now we will look up and know that everything is changing. Somewhere, a star is dying. Somewhere, a rock is crossing Earth's orbit. Somewhere, a black hole is feeding. Somewhere, a galaxy is flashing from an event that happened before humans existed. And tonight, maybe for the first time, a machine will notice it within minutes. That is magnificent. It is also a little frightening, because knowledge has a cost. Once you can see the warning lights, you cannot pretend the dashboard is dark. And maybe that is the real meaning of Rubin Observatory. It is not just the world's largest camera. It is a new relationship with the sky. The universe is not becoming more dangerous. It is becoming more visible. The danger was already there. The motion was already there. The explosions were already there. The near misses were already there. We are simply losing the ability to look away. That may be what progress feels like. Not comfort, not certainty, but a sharper kind of awareness. A species that once told stories about constellations is now building machines that send alerts when those constellations change. That is either absurd or beautiful. Maybe both. And it reminds me why I still love astronomy. Not because it makes the universe simple. It never does. But because every better instrument reveals that our old picture was too still, too small, too quiet. The sky was never a painting. It was a storm seen from very far away. And now, for the first time, we are beginning to hear the rain. So here is the question I want to leave with you. If the sky starts sending millions of alerts every night, do you think that makes humanity safer or more anxious? Should every possible threat be made public immediately? Or should scientists filter the noise before the world sees it? Some people believe more information always means more safety. Others believe too much warning can become its own kind of danger. I want to know which side you are on. Because the next great discovery may not come from staring at one beautiful object. It may come from noticing that one tiny point of light moved.